Good evening, Dr. Z. So this is my video for the assignment for week number 10. So in this one, what I've done is this is a machine learning based time series analysis on daily stock returns. Now, in the course website, we were given two options. Either we could use the store data that was given over there, or we could use the stock data. So in this one, I opted to go for the daily stock returns one because the file that I was using, I'm also using this for my project. So this one is just like a mini version of it. Even though it's not entirely related to my project is based more on the earning surprises rather than the daily stock return. So this one is different from my project. But since I already had the file and I didn't have to work that hard, if I did for the store data, so that's why I chose this. So just going through the introduction, this assignment, basically uses machine learning for forecasting the daily stock returns and evaluating the predictive model using backtesting. So the data I have chosen is from the CRSP daily stock data set. So basically the entire database of every single stock that they had. The data is from 2015 all the way to 2024. So that gives us a 10-year span, which is good enough for this one. And so for the performance analysis after that, the goal was to assess whether the machine learning model could generate signals that translate into profitable trading strategies, right? So let me go down a bit more. So, the first thing always is to, do the data preparation and the cleaning. So, basically, first of all, I removed any non-numeric return values, that were there in the return column. Infinity values were removed, and also any empty values were also removed, and any stocks that had fewer than 15 daily records were dropped as well to maintain consistency and ensure that the data was not skewed. So let me also show you the code over here. So when we come to the code, this was the where is it? This was the original file, the original CSV file that was used for our analysis. So first, to clean this up, like I said, to to remove the uh, missing values, to remove the missing values rows over here, then remove the infinity values as well, and to drop the stocks with fewer than 15, lower, fewer than 15 days of data for those stocks were also removed as well. And then the clean data set was saved to CRSP cleaned. Um, my original data set had from 2010 to 2024. Then I had to remove from 2010 to 2015. And so therefore, this was the one that was the one that was cleaned up and then used in later. So we move on to this file, but before that, let me jump back onto the report. So over here, the feature engineering was done basically. Um, so we can see over here that the data was first, made sure that it was sorted properly. Then we had to do the lag feature. So we had to create lag returns for this one, since we're doing time series analysis for the returns. So, 1 day lag, 2 day lag, 3 day lag, 5 day lag, 10 day lags, where all of these lags were created, for our analysis before we move on to the machine learning part. And then, the target um, column was also created, which was the returns that were generated by the original file. So that was our target variable. So this was, you can also say that this was our benchmark. And so, I had saved that to the file called CRSP with lags. So this is the one that we're going to be using later, especially in back testing. So jumping back onto the report, like I said, these lag returns of 1, 2, 3, 5, and 10 days were created. The target variable was created, which was the next day's return. And so that was saved. And then we move on to the model training and evaluation. So in this one, I started off from the random forest one, but that wasn't giving me a really good result. So I had to go with the gradient boosting regressor, which is another machine learning algorithm, which you would already know. Just mentioning it right over here. And then, input features including lag returns, law of transform, volume and inverse price were the ones that were used. And then there was a time aware split that was done. So I had to split the data set for a training one and then a testing one. So anything that was before 2022, so between the years of 2015 to tw- uh, before 2022, so 2021, were used for training, and the rest was used for testing. And then basically these were the metrics that were used. So RMSE, MAE were calculated to assess the absolute prediction error. R squared was also used, and then directional accuracy was computed to assess, like how accurate is the model. So jumping back onto the model training one. So this is the code over here. As I was saying, I already have the columns which were needed, and so we move on to over here. The time split was done right over here for testing and training. The right columns were used. Number of estimators were 25. Learning rate was zero point 0.1. Um, then we move on to further down, and then these were the results that were supposed to be printed. So let me show you what came out to be. Um, Hold on just a second. Okay, so this was the result right over here. The RMSE was 0.04, testing MA was 0.019. R squared was in the negative. Directional accuracy was 48.63%, which I had saved to this file called predictions boosted CSV. So now I do understand the R score was below zero, which is not the best thing, but the accuracy was 48%. And basically, I didn't want to improve the model, a lot, because this is not for the purposes of a project, but it is for the purposes of the assignment. And the assignment purpose is to show that we are basically learning. We know what we are going along with it. So the problems could arise from not having enough variables to test to predict the returns that are coming in, or there might be another problem. But we just went with the 48% accuracy. There usually, if we are around 60% accuracy, that's a pretty good benchmark for academic purposes. But for the purposes of this assignment, I just wanted to move it along to the back testing and see basically the time series analysis is even working or not before I even jump ahead and try to better it, right? So let's go back to the code. And so after that, we move on to the back testing. After we had made the model. So also let me jump back to the report as well. Okay, so in this back testing, what I did was that I chose the top 50 stocks that I had according to their PER MNO, which were basically the most highly traded ones, the more liquid ones, the more stable ones. Those were the stocks that I chose. And I had a long short trading strategy. So the trading strategy logic was that I would choose a long position, which means that I would buy the stock if the predicted return was greater than zero, short position if the predicted return was less than zero. So you can assume that this is more of not exactly a high frequency trading, but like a moderate frequency trading. So basically, I would be buying and selling stocks almost each day for these 50 stocks that I have chosen. And instead of by the minute, or just like using a long-term strategy where I just keep on to the stocks and basically trade much less. And so the daily returns were computed as the actual next day return times the position, and the benchmark return was also computed as the equal weighted average return across the 50 stocks. So we had the benchmark and also the strategy that I had, which was basically the long position and short position that I would take. And the portfolio construction was that each day strategy returns were average across the 50 stocks to simulate a portfolio, and cumulative returns were tracked for both the strategy and the benchmark, right? So jumping back onto the code over here. So here it is that I'm choosing the 50 50 stocks out of the data set that were the most liquid, and then aggregate daily portfolio return was also made, which of course comes to benchmark returns, which we are going to be comparing our strategy to the benchmark. So that was that, and then we had to see like what was our performance based on the entire period that we were choosing. So I did not use a period, let's say from 2022 to 2024. Instead, I just used the entire thing. So from 25th. So my trading strategy, I'm assuming that I am doing the long positions and the short positions from 2015 all the way to 2024. So I have after running this code, I have the result and the plot that I have made. So let me show you that what came out to. Okay, so after running the code, this is the output that came out to be. The top 50, stocks that I chosen, all of them are over here. So it's not just a random thing that I'm doing. I am actually selecting these stocks instead of just like going with one stock or two stocks. I'm going with 50 stocks. That is like a full portfolio. So the total return, which was the benchmark, which was from the original data, from the period of 2015 all the way to 2024, had the return of minus 2.38%, and the total return from my strategy came out to be at 4.16%. So this is much higher than the benchmark. And of course, the reason why that's coming in is because of the nature of the data, that I chosen from 2015 to 2024, which also includes the COVID years where stocks took a really big hit. And also, of course, we have the elections, right before the elections with the unpredictability that was coming in. So that also, comes into why the returns, were not as much as, they usually are. The max drawdown was minus 19.77%. And after that, let me show you the figure that came. And so here is the figure. So we have the long short strategy, which is the solid line right over here. I am not good with colors, so I'm just going to go with orange. Orange might be the color, I'm not sure. And then the benchmark is the dashed blue lines over here. So we can see for the most part, the strategy that I have chosen for myself actually yielded better returns than basically what the benchmark was. So the back testing proved out to be successful, over here as well. Basically we can see that from the period of 2022 um, to basically we can say all the way up till almost 2024, at the beginning of 2024, we can see that the returns were more of negative, both for the benchmark and for the long short strategy. But after 2024 begins, we can see that the returns have become better. So, like I said, the average return that I had was 4.68%. But you can see that it went as high as over 10%. You can say maybe close to 11 or 12%. Which is really good for 2024. So 2024 turned out to be a great year for the stocks that I had chosen. And the strategy that I had chosen. So this was my assignment for week number 10. I hope you like it. Thank